Hello, Algebra 1B students, and welcome to a session of notes here on some concept known as permutations. The word itself is kind of challenging to say, but it's really not too hard, I think you will find. Okay, so a permutation, what it is it is an arrangement of things in which the order is important. Okay, what these are used for, so let me finish here, is important. Okay, what these are most commonly used for, say you're in a race. Say you're in a race with 50 other people, okay? So 50 people are in a race, and you want to know how many ways that you can finish first, second, and third. First, second, and third. What you can do is you can find how many different ways that could possibly happen, assuming everyone was at the same speed and everything. Okay, so you guys know I do 5Ks and things like that. Say there were 50 people in a race, and first, second, and third place get a prize. Essentially what you end up doing is something known as 50 permutation 3, and that finds you how many ways that people can finish in the race. Some things we're going to look at first are arranging letters, okay? So we're going to be giving you different words, and you're going to pick how to move the letters around, okay? There's a few ways to look at this. So first off, July. July is coming up. There are 4 letters in the word July. 1, 2, 3, 4. And we want to see how many ways we can rearrange them, switch them around. Okay, so if we think of this, there are 4 letters. Okay, what we can do is we can think about replacing them. So let's think the first spot. We're going to pick of those 4 letters, one of the letters. How many ways can I pick that first letter? Well, there's J, U, L, or Y. So there's 4 ways. Okay, now let's say I pick the letter J. Okay, how many ways then do I have for the next letter? We're going to multiply by the number of ways for the next letter. Well, if I already use J, I have U, L, Y to work with. So let's say I have 3 different options. Okay, and let's say I pick Y. Well, then I have 2 options for the next one. You can say U, and then L could be the last one. Okay, so notice we go 4, 3, 2, 1. We kind of multiply the different options, decreasing. Well, with your graphing calculators, 4 times 3 times 2 times 1, that gets you to 24. There are 24 ways in which you can arrange all the letters in July. Now let's say we just want to arrange 2 of the letters. Okay, again, there are 4 total, so 4 letters. We want to take 2. Okay, so we have 2 spots to fill out. We have 4 options for the first letter, and then if we use one of the letters, we only have 3. So we just need to multiply 4 times 3, and that gives you 12 different ways. Okay, try out mouse. Okay, pause the video here maybe, and think how many ways can you arrange the letters in mouse. Mouse. If you pause it and try it out, that's fine. Notice there are 5 letters. We want to move all of them, so we can do 5 times 4 times 3 times 2 times 1. And we're multiplying. Type that into your calculator. And you end up with 120 ways to rearrange the letters in mouse. Okay? And here's one as well, orange. And we just want to arrange 3 of them. 3 of the letters in orange. So let's count up how many total we have. 1, 2, 3, 4, 5, 6. And we are taking 3. Okay, so 3 spots. The first option could be 6, the second one could be 5, and the third could be 4. So 6 times 5 times 4 gives you 120. 120 ways. Okay, arranging letters, pretty easy stuff, hopefully, for the most part. The next word we're going to worry about are called factorials. What? Permutations, now factorials, all new words coming at you today. N factorial. What in the world is that? Okay, it's not a very loud N, but what it is really you end up taking a number, and it's going to look real confusing. You're going to take N times whatever that number is minus 1, times whatever that number is minus 2, times whatever that number is minus 3, and so on, all the way down to 1. I know, you're scared. You probably don't know what's going on. But I'll show you how easy this is. 5 factorial, what that looks like is 5 times, well, 5 minus 1 is 4, and 5 minus 2 is 3, and 5 minus 3 is 2, and 1, and that's where we stop. 5 times 4 times 3 times 2 times 1. And we just did that above, you get 120. Okay? For example, another little example here. Okay? If you had 7 factorial, that's just 7 times 6 times 5 times 4 times 3 times 2 times 1. Boop, 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 boop. All from there. Okay? These numbers get big, fast. If you had 20 factorial, you'd write all those out. But it's not too bad. Anyway, for letter B here, we can also divide factorials. Okay? Here's the cool thing with those. All right? If you were to write this part out, so 11 factorial, that is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the 11 factorial. 8 factorial in the denominator is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We talked about multiplication, how they can cancel if it's in the numerator and the denominator. So what ends up happening is the 8's cancel, the 7's, the 6's, the 5's, the 4's, the 3's, the 2's, and the 1. And really, all you have to do is 11 times 10 times 9. Hopefully you find this stuff is not too hard. I know I did it out of order there, but that should still work. 990 is what you would get if you did 11 times 10 times 9. Okay? So just real quick, I'd like you to try one. So write this one off to the side. Okay? Try out, we'll say 15 factorial divided by 10 factorial. Okay? Pause the video, type it in there, and then try it out. As you're doing that, 15 factorial is really 15 times 14 times 13 times 12 times 11 times 10. And then all over 10 factorial, essentially, those would cancel. 15 times 14 times 13 times 12 times 11 gives you 360, 360. You got that number, you're on the right track. Okay? Applications of these, where it's important, so like with my race. Permutations, the biggest thing is order matters. Order matters. Permutations, think permanent marker. Permanent. So the order matters. Okay, we're going to learn something tomorrow when order does not matter. Permanent order matters. So a band has written 12 songs they wish to put on a CD. Order matters as to how the songs are listed. The CD can only hold 9 of the songs. Okay, N, PR, that's what we're going to be using here. N is always the bigger number. And the bigger number we have is we have 12 total songs to pick from. R is always going to be the smaller number, or it's the same number, so that's your rate. And we're picking 9 of those songs. So we have 12 things, we're picking 9 of them. Order matters. NPR, so the number of things is 12. We want to permutation those, and 9. So 12p9. Now, look at the graphing calculator. I'm going to show you how to do this. Okay? the first step is to type in the n number, so 12. So do that with me. Then you're going to, so type in n, then go to math. Math is right here. Over to PRB. And then number 2. So hit number 2. Then you need to type in the last number, so 9. Okay? 9. Once you do that, just hit equal to, and you get the total number of ways that CD could be made up. 33600. Okay, 79 million. Let me just run through that again. 12P9, 12. Math over to PRB to 9. Makes your life a lot easier. Okay, there are some practice problems that follow, and there are some questions that follow this set of notes as well. So just be careful, practice these. You can use your calculator on a lot of them, and just know that for a few of them, like 19 through 24, you are just determining which one is bigger, So you're going to practice typing those into your calculator and determine which number comes out to be larger. Okay, try those out. Thanks for watching, and good luck.